All right, this is your day 3 homework. I'll do a few problems on here, and hopefully the explanations help. So I'll start with number 2. You'll notice that you have a square root of 125, square root of 2, and square root of 2. There's kind of an interesting way to solve this, in that if you can recognize right now that those two, if you multiplied those together, you're going to get square root of 4, and square root of 4 is something you can take the square root of right away. So really, I would do that separately. I mean, everything's going to get multiplied together, and we still need to deal with the 125. But for right now, we can take care of this thing right away, and that's a 2. Now this whole part is gone. We've already reduced it to a 2. So we'll bring that out front for later. We don't know. We still have to deal with the 125. The 125, we're looking for perfect squares that can multiply to be 125. And the obvious one is 25, because that's a perfect square. And if you multiply that by 5, you get 125. So when we take the square root of 25, which is what we're looking for, that's going to turn straight up into a 5, and we have square root of 5 left over. But remember, we have this 2 hanging out down here. So really we have 2 times 5 times square root of 5. And the two numbers that are not radicals can be multiplied together. And so we end up with 10 root 5. There are other ways to solve this one. We could have multiplied the 125 times the 2 and times the 2 right away, and then looked for just one larger perfect square and taken that out and simplified it that way. That would have worked as well. So there's multiple ways to solve these problems. I chose this way. All right, how about, should probably do a cube root multiplication. Let's deal with 4. So this is cube root of -5 times the cube root of 25. They're both cube roots, so we can multiply these together, the numbers underneath the radical sign. This ends up being cube root of -125. And then we'll look at our charts for the cube roots, if there's a perfect cube in there that can multiply to be 25, or if 125 is a perfect cube. And it is, but again, because of the negative sign, the radical is asking what number raised to the third power is -125. That has to be -5. So this can straight up, you can just take the cube root of it, and you end up with -5. Right, I'm going to leave number 5, and number 5 is pretty interesting, so I want to leave that for you. I don't suggest multiplying them together right away, but you can. How about 8? 8 looks really fun. I'm sure you'll love it. So you need to deal with the number the same way we have been from day 2. Find two numbers that multiply to be 162. One of them should be a perfect square. So if you check it out, 81 works. 81 times 2 makes 162. So we figured out the numbers. But then remember, our trick with the variables is that we've decided if we can put them in chunks of 2, they would be squared. Each chunk of 2 would be a variable squared. And a square root of a square is just the term that's in there. So it can basically come out of the square root at that point. So what we decide to do is write out all of your variables in chunks of 2, as many as you can. This would be square root w squared, it's 2 of them, square root w squared, square root w squared, now we're at 6, and square root w makes 7. Square root y is in the mix, but nothing can happen with it. And then square root of z squared is a group of 2, and there's none left over. So as you recall, any of the chunks of 2 that we were able to make, they all get to come out of their square root, and just be a single variable. So this is going to be w times w times w, and then we'll have a z over there. They all got to come out. The other thing that comes out is that we did make square root of 81, and 2 made 162, so 81 becomes the 9. That's the square that we can take. All of the other ones, namely the square root of 2, the square root of w, and the square root of y, they cannot be simplified. They are stuck inside the radical. So since they're all radicals and everything's being multiplied, we can rejoin them all under one radical. So I like doing this part first, just so we know that that stuff is already taken care of. Square root 2 w y. They're all under 1 because they're all being multiplied together, and they are all the same type of radical. Like they're all square roots. And then for the other guys, they all came out 9, and then we had 3 w's multiplied together, so that's w to the third, and then we had a z. So that is simplified. Let's try 11. So 11, notice right away you have a 12 out front. You're just going to have to save that guy for later because it's already simplified, but we can't multiply it by anything because everything else is inside of a radical. So it's going to hang out here. It's just a 12. Then we got to deal with this cube root of -8. Deal with your numbers first. And we'll notice that 8 is a perfect cube. It's on your list. And the cube root of 8 is 2. But it's negative. So that means that the number that is raised to the third power to make 8 is a -2. So that comes out right away. That's just times a -2 now. And there is no more numbers underneath the cube root because it was a perfect cube. And recall that if this is a cube root, we want to put all of our variables in chunks of 3, as many chunks of 3 as we can make. So that's going to look like cube root of k to the third times by cube root of k, and there's only one left over, right? We used all 4 now. We took a chunk of 3 out, and then there's one left, so it's just a k. The last piece is the m, and you can't put that in a chunk of 3. It's only one of them. So cube root of m. All right, at this point, any chunks of 3 that you made of the variables, they're going to cancel with their radical. So this is to the third power, and this is a cube root. Those cancel out, and you just have a k. These guys, however, they're stuck inside. They can't break out, so you can put them back together. This will be cube root of k m. And then we haven't dealt with our numbers yet. That's just, you multiply them together because they're both non-radicals. So this is a -24. So your final answer is -24k cube root km. And be careful, this is really sloppy because it's hard to write on this, but this 3, make sure it's really close. Make sure it's really close to your radical so it doesn't look like -24k to the third square root km. It's -24k cube root of km. All right, and I'll start off number 12, but I'm not going to finish it because I don't want to do all your work for you. Although I'm having just a blast. So they're both square roots. You can multiply them together. When you do that, you'll get k to the 9th, s, 8, and then one more is 9. It looks like 5, but it's an s. T squared and t, together they are t to the third. And then r and r make r squared. And the next thing you got to try and do is, it's going to take up a lot of this space here. But since it's square roots, the index is a 2. So you will try and take out all of your variables should be in chunks of 2. You'd start by saying, all right, here come the k's. This is k squared, k squared, k squared, k squared, that's 8, k single. So that makes 9 k's. We got them in groups of 2. Each of these guys will end up breaking free, just being single k's. Very hard to write a k. This guy is sad because he can't leave. You have to do that with all of the variables, break them out in chunks, and then put back together the variables that came out of the radicals, and then put back together the variables that had to stay inside the radical. So that's your plan of attack. All right. Happy simplifying.